Okay, this presentation we are going to look at numerical programming exercises. These will feature arrays, random numbers, comprehensions, and so on. So it's a set of numerical programming exercises that were devised for NumPy, which is a package in Python for mathematical computing. And this is the second set of exercises. So it's going to be a bit more advanced than the first one. Just as a remark, this is Julia version 1.6.1 and we are using Jupyter notebooks. And this is aimed at undergraduate students of mathematics, science and engineering in the early part of their undergraduate studies who are new to programming and new to Julia and so on. Okay? So the first exercise is create an 8x8 matrix and fill it with a checkerboard pattern. So what we're going to do here is start off with the basics. What we're going to do is set up a matrix there full of zeros, okay? And it's 8 rows, 8 columns. That's fine, and it's all zeros. Now I'm going to be a bit more precise about what we're doing. So I want to set it such that they're all integers, okay? So that's why I'm putting in this additional argument specifying the type. Okay. On an ongoing basis, I'm going to be more and more precise about types. But earlier on, I just want to build up code vocabulary. But as we progress, we're going to get a bit more particular about that. Particularly as that is an important feature of Julia. Okay. So what I'm going to do here is arbitrarily set the 0, 1, 0, 1. So just actually start in the top corner with a 0. Okay. So what we're going to do here is use ranges. And this would be essentially a range of values that give odd numbers from 1 to as far as we need. Okay. And we'll just pick out 8 in this case and just sort of say 1 to 8. All the odd numbers between 1 to 8. And likewise, this will pick out all the even numbers from 2 to 8. Okay? And there's other ways of doing that, but that's essentially sort of say we're going to pick out the odd number rows and the even number columns and set them to 1. Okay? So that's all that does. That's just to start us off. Let's run that. Okay. So far, so good, but we actually have to do it one more time for the odd number or the odd number columns, which is to say the even number rows. Okay, so we just have to repeat the process here a second time, and that gives us our checkerboard. Okay, so a little bit of guile is required there for dealing with the rows and columns. Okay, just remember that little dot there, because it's multiple inputs, so that just it's an array, 2 by 2, two-dimensional array. So we're giving each value 1. So just actually dot equals there. Okay, that gives us what we're looking for. Now there's alternative approaches, and this is comprehensions. Comprehensions are a bit more advanced for people new to programming. So, but I'll just show you how it works. A comprehension will work and see if we can use it in this instance. Okay. So just to sort of, I won't go into comprehensions too much. I'll just take up too much time, but just actually demonstrate it quickly how we might use it in this case. So essentially, this is an alternative way of setting up a 0 by 0 matrix. Okay. 0 for I in 1 to 8 and j in 1 to 8. Okay. Perfect. So we have an expression here for, and then some iterations there, some ranges. Okay. So I won't get into too much into that, but it's a very interesting way of doing things. Okay. So what we could do here is just see if we can advance that a little bit more. And I plus j, that's an expression. And we're going to iterate it over I and j and create an array out of that. So this is sort of essentially the sum of the row number and the column number, I plus j. Okay? And yeah, so first row, first column, 1 plus 1 equals 2. Okay? Or the value in the first row, the name of the first row, and the name of the first column. Okay, so that. Okay. now. So essentially what we have here is even, odd, even, odd. Okay. So that's just, how do we turn that into ones and zeros? Well, what we could do here, 1 plus 1, remainder when you divide it by 2 is 0. 1 plus 2, remainder when you divide it by 2 is 1, and so on and so forth. That'll be the same for all odd and even numbers. Okay, so essentially what we could do here is create the same checkerboard expression using a comprehension. Now there's a little bit of guile there, but by the same token, this is what the point of these exercises, to build up code vocabulary, build up multiple ways of approaching problems, and that's what we're aiming for here. Okay, so we spent a lot of time in that, so I'll have to hurry up now with the rest of them. Create a 10 by 10 array with random values and find the minimum and maximum value. This one is fairly straightforward, really. So that's how we set up a 10 by 10 array with random values. Okay, and Z min and Z max, they are assigned the values minimum of Z and maximum of Z, and it just created as a tuple. So minimum and maximum, that's all we need, really. So that's a very straightforward one. There's also extrema here as well. Okay, and that just picks out the minimum and maximum value and creates it as a tuple. So it's essentially this a combination of these two together. Okay, so that's spare. Okay, create a checkerboard 8 by 8 matrix using the repeat function. Okay, now formerly this we would have used the repmat function, but it's been deprecated. And if you're looking at the equivalent from Python, I think it's tile. Okay, so what we're going to do here is just set up a very simple matrix to get us started. That's how we would create a very simple matrix. Okay, and essentially repeat, or repmat as it used to be, will repeat 4 rows and 4 columns of this. Okay, so I'll tell you what, and that will give us an 8 by 8. Just quickly, I'm going to try out this. So that gives us 4 rows, 4 replications. Okay, and along the rows, and then 4 replications along the columns. So just run that. Now that's our checkerboard. Okay, so that's the core matrix, and then the dimensions that you're going to expand, and how many expansions on each dimension. Okay, or how many repetitions on each dimension. So that'll do it. Next one. Normalize a 5 by 5 random matrix between 0 and 1. So normalization is an expression of a number in a set of numbers, in an array of numbers, as a proportion between the minimum and maximum. Okay, so for example, if we have the minimum is 5 and the maximum is 10, the normalization of 6 will be 0.20, because it's 20% of the way between 5 and 10, 20% of the way between the maximum, the minimum and the maximum. Okay, so it's a sort of height proportion, a height expressed as a proportion from the minimum, if you get me. It's a bit of a, you get the hang of it, that's all. So again, what we have to do here is take out the minimum and maximum. Okay, Z min and Z max. Okay, and this is the range here. Okay, between the max and the minimum. Okay, and so what we're going to do there is subtract the minimum from each number in Z. Okay, and remember the little dot there, and then divide it by the range between the maximum and the minimum. Okay, so that's it, really. That's a straightforward enough one. So you're sort of creating scalars there, Z min, Z max, and constructively Z max minus Z min, and just carrying out those operations on Z using those scalars. So that's just why we use those dots. But actually, it's very straightforward, really. Now, I tell you what, we're going to take a break after this, and we'll come back to the second set. Multiply a 5 by 3 matrix with a 3 by 2 matrix, real matrix product, okay? So it doesn't really tell us what we have to use there. So what I'm going to do here is use ones, okay? So a 5 by 3 matrix, let's use ones, and a 3 by 2 matrix, again, let's just use ones. I could use zeros there, but that's not actually interesting when we look at the output there. So I'm going to use ones in this case instead, okay? 3, 3, 3, 3, okay, so on. So actually, what I want to point out that is just to sort of see that if we go 4 by 2, sorry, 5 by 4 times 4 by 2, there we go, and so on. Just makes it a little bit interesting to see what the output is like. Okay. If we had zeros there, you wouldn't sort of... It's just, I think that's just interesting there, just to sort of see that it turns out that it turns into fours there. Okay. It'll tell us if the dimensions will not work out. Okay. So I go 3 by 4 here. Yeah, problem. Okay. So let's just put that back to the way we wanted, or what we were told at the start. There we go. So I've been at this a while, so what I'm going to do here is finish this presentation and then just start up a second presentation for the rest of this set. So we'll leave that there.